Algebra 2, Chapter 2.2, Exercises 17 through 22. These are going to be real-world applications of solving absolute value equations. As always, I encourage the viewer to work problems ahead first, then play the video to see if you got it right. It gives you another opportunity to learn. In this set, I'm going to perform problems number 17, 19, and 21, the odd numbered problem. The bottom of the river makes a V shape that can be modeled with the absolute value function, and here is the absolute value function. D of H equals 1/5 times the absolute value of quantity H minus 240 minus 48. Get skinnier pen here. Where D is the depth of the river bottom in feet, and so this is going to be D here on the y-axis, we call it that, and H is the horizontal. So H is your horizontal distance to the left-hand shore. So we're talking about this coordinate plane right here. Okay. A ship risks running aground at the bottom of its keel, its lowest point, and there is that keel. Reaches down to the river bottom. Suppose you are a harbor master and you want to place buoys where the river bottom is 30 feet below the surface. And that would be on each side of the center. How far from the left-hand shore should you place the buoys? And here we can see the 0 and 40. So 30 feet would be about right here. And just extending to the right, it looks like we might have one buoy about 160 feet from shore. And we continue on the other side, maybe the other one's going to be about 320 feet from shore. So this estimate lets us know if the equation we solve is accurate, or our solution is accurate rather. So let's go ahead and substitute for D. We have 30 feet below the surface. Okay, we're looking over here. So in this case, D that we're going to start with is going to be equal to negative 30. Now you got to be careful about this, because if you put positive 30, that could mess you up. So I'm going to put our first equation here, and I'm going to kind of work with the rule we have left to right. So negative 30 equals 1/5 absolute value of quantity H minus 240 and minus 48. So we're going to go about solving this equation. The first thing we're going to do is add 48 to both sides of this equation. And when we do that, I'm going to come over here. The space we have, I'm going to work it like this. We're going to have on the left side negative 30 plus 48, so that's going to be 18. And 18 is going to be equal to what's remaining, which is 1/5 the absolute value of quantity H minus 240. Now this is key, this first step, in that when you isolate an absolute value bracket here, for you to have any solutions, you have to have 0 or greater, this expression being equal to. In this case, we do. So let's go about solving. And we're going to get rid of this 1/5, and to do that, we're going to multiply both sides of this equation by 5. And what happens is, on this right side, we have 5 times 1/5 equals 1. So what we have left on the right side is absolute value of quantity H minus 240. And when we multiply 5 by 18, that's going to be 90. Now you realize I switched the sides of the equation. And so now we can set up two equations from what we have here. I'm going to write what they are, kind of go over here. One of them is going to be h minus 240 equals 90. And the other equation is going to be, I hope you know what it's going to be. It's going to be h minus 240 equals negative 90. Now when we solve for h, we're going to have our solutions. So on this left equation, if we add 240 to both sides of the equation, we get h is equal to 90 plus 240, and that's going to be 330 feet. And then on the other equation, if we add 240 for both sides, we get h is equal to negative 90 plus 240 is going to be 150 feet. And so these will be our answers. And we can verbalize. Let's just look at our graphic. Well, I picked 160 being the left side. It's going to be closer to 140. I'm just marking where 150 is approximately. And I said 320. Well, it's going to be closer to 330 feet, so something like this. So yeah, pretty close. I'm just going to draw the arrows here. That's that. This one's going to be 150 feet. So just to verbalize this, the buoys, I guess buoys will be placed (150) and 330 feet from the left shoreline. Left shoreline. Oh, it says shore. Just put shore. And so that'll be it. Next on our problem to look at is 19. Again, I invite the viewer to pause and work ahead to see if you got it right. Okay. A flock of geese is approaching a photographer flying in formation. So we have this photographer here. I'm just going to make kind of a tripod as a camera on it. So that's going to be represented in there. That's such a pretty camera. But anyway, we have a flock of geese that's flying in this direction. And so the initial placement of the geese, the head of the geese, is 300 feet away from the photographer. I hope you had the opportunity to see geese in flight. Very beautiful. So 300 feet away, and the speed, I'm going to draw the arrow, is going to be at a steady rate of 30 feet per second. So the photographer starts shooting when the lead goose is 300 feet horizontally from her, and continues shooting until it is 100 feet past. And so we're going to continue shooting until we are 100 feet past. And then find the times after shooting begins that the lead goose is at a horizontal distance 75 feet from the photographer. So here we're going to have, here's the horizontal distance of the photographer. We're going to have 75 feet here. and over on the other side, we're going to have 75 feet. So we're shooting here, and we have 300 feet. How long is it going to take for us to get to the level of photographer? Well, it's going to take at 30 feet per second. That's going to be 10 seconds. So we know we are at, I'm just going to write 10 seconds right here. And so one of these numbers is going to be greater than 10 seconds. The other time is going to be less than 10 seconds. So we know that. Let's go ahead and find an equation for this if we can. The distance away from the photographer, we know, we'll say the geese are flying at 30 feet per second, so we're going to call it 30x. Why not? And the distance away, we're starting at 300 feet. So if we take 300 minus 30x, I hope you can see that if at time 0, we plug in 0 for x, we're going to be 300 feet away. 10 seconds later, if we plug in 10 for x, we're going to have 300 minus 300, or 0. So this expression matches. Now, we can also account for the other side. As the lead goose flies past the photographer, we're going to have what amounts to an absolute value relationship, because this absolute value bracket will apply on the other side. So in this case, when x, if x is 40, or x is 12 seconds, we can figure out that 300 minus 360, well, that'd be 60 feet away, but that'd be negative, but it'll make it positive. So either negative or positive, this expression covers the distance from the photographer given a certain time x. Now we want to find when the lead goose is 75 feet away. So that's what we have. And we know, looking at the equation purely now, since 75 is a positive number, we know we're going to have two solutions. But that really makes sense from the physical setup we have here. So how are we going to solve this? Well, it's going to be similar to the way we did the last problem. We're going to have two equations from this. We're going to have 300 minus 30x is equal to 75. And what else are we going to have? I'm going to come over the top. We're going to have 300 minus 30x is equal to negative 75 feet. So now we can just solve for x. Well, there are different ways to do this. If I want to get x on one side, well, let's do that. I'm just going to, since we have x on the left side, we're just going to leave x on the left side and subtract 300 from both sides. So what we get is negative 30x equals 75 minus 300, which is going to be negative 225 feet. And then if we divide by negative 30, so x is going to be equal to a positive number. What's going to be 225 divided by 30? Put 30 here. How many times does 30 go into 22? Not at all. I think we go to 7 here. Yeah, that's right. And 7 times 30 is 210. And then we bring down 15. And then we bring down this 0 here. So how many times does 30 go into 150? Well, we'll go in 5 times. So, and then we multiply through, we get 150. So we get our remainder of 0. So we will say our equation shows our answer will be at x, or equals 7.5 seconds after shooting. And now for this other equation, we have minus 300. So we get negative 30x equals negative 375. And if we divide by negative 30, we're going to get x equals 12.5. So we got 7.5 seconds and 12.5 seconds. And at x equals 12.5 seconds. Those will be our answers. Okay, let's go on to our last unknown problem we're working at here, number 21. Again, I invite the viewer to pause, work ahead. Terry's trying to place satellite dish on the roof of his house at the recommended height of 30 feet. His house is 32 feet wide, and the height of the roof can be described by the function h of x equals negative 3 halves times quantity x minus 16 plus 30 plus 24, where x is the distance along the width of the house. Where should Terry place the dish? So what we're going to do is we're going to take h of x and let it equal, we want the recommended height of 30 feet. So we're going to let that equal 30. So h of x is equal to 30 feet. So let's write the equation out here. 30 is equal to negative 3 halves, absolute value of quantity x minus 16 plus 24. We go ahead and we continue our solution here, and the first thing we're going to do is subtract 24 from both sides of the equation. So we get 6 is equal to negative 3 halves, absolute value of quantity x minus 16. The next thing we're going to do is solve this right side by multiplying by the reciprocal of negative 3 halves, and that's going to be by negative 2/3. And 6 times negative 2/3 is equal to negative 12 divided by 3, so that's going to be negative 4. And that is going to be equal to the absolute value of quantity x minus 16. Now, going back to the last video lesson, what do we know if we have an absolute value expression equal to a negative number? There's no solution, so I'm going to just summarize no solution. And then to further explain, there is no place on Terry's roof group where the height of the dish would be 30 feet in elevation, or where the height of the house would be 30 feet off the ground, above ground. So what we'd have to do is we'd have to try, maybe there would be a lower height we can place the dish, maybe at 20 feet height. Anyway, this is going to be our answer to problem 21. I invite the viewer also to look at problem 22 to see where a mistake was made in this solution of an absolute value equation process. As always, good luck and thanks for viewing.